Hello everyone, I'm Kinoshita of Tottori University, Japan. Today, I'd like to talk to you about body part attention probability for measuring gaze during impression word evaluation. A person's impression is important on formal occasions, such as weddings and parties. For example, when we attend a wedding ceremony, we take care to make an appropriate impression on the attendees. We analyze the impressions made by individuals in images photographed in formal scenes. We assume observers are seeing these individuals for the first time. When we ask observers about the impression worth, many observers are likely to provide the same responses. For example, if we ask observers whether the person in the left image is beautiful, we assume many observers will respond, "She is beautiful," and some will respond, "She is not." We suppose we ask whether the person in the right image is clean. Clean, like beautiful, is an impression word, so we should obtain similar results. We consider how to automatically predict the impression words describing individuals in images. To do this, machine learning and deep learning techniques are usually applied. In recent years, methods of incorporating the gaze distribution into machine learning and deep learning techniques have emerged. These existing methods should improve the prediction accuracy in practice even when a large number of training samples cannot be collected. However, these existing methods don't consider how to handle the gaze distribution in terms of impression. In cognitive science, several analytical studies have reported how observers view an image of a person and form impressions of him or her. In these studies, observers evaluate impression words to the image of a person, and their gaze locations were measured. As a result, the observers spatially located their gaze on various body parts, mainly the face. However, these studies don't discuss how to incorporate the gaze distribution into practical applications. The gaze distribution should be represented probabilistically when applying machine learning and deep learning techniques. Therefore, we propose a method for probabilistically representing the gaze distribution, indicating which body parts are frequently viewed when observers evaluate an impression word for body part in an image of a person. An overview of the proposed method is shown below. First, we show the images and measure the gaze distribution when observers evaluate the impression words we given for formal scenes. Second, we calculate the pixel attention probability of each observer for each image. We have to pay attention here. The people in the stimulus images have different postures. This means their body regions are not aligned. Therefore, we define probability represents how many gaze locations are concentrated on body part when participants observe stimulus image in the task. We explain the details of our setup for measuring the gaze locations. We assigned the observers 6 tasks. 24 participants participated in the study. They consisted of 12 males and 12 females. The average age was 22.4 years old. We used 96 images consisting of 48 males and 48 females. This is the scene measuring the gaze distribution. We used a gaze measurement device and a 24-inch display for gaze location recording. We compare the probabilities in the tasks for hands or feet. The left figure shows the body part attention probability for the hands tasks. The right side shows the probability for the feet tasks. When a body part is included in the task, it's more likely the participant's gaze is drawn to the body part itself in the task. Furthermore, we compared the probabilities for beautiful, clean, and cute. There is a tendency for the frequencies of the body parts viewed by the participants to change if the impression word in the task is changed. To conclude, we proposed a method for representing a probability indicates which body parts are frequently viewed when observers evaluate impression words in stimulus images. There is a tendency for the conditional probabilities of gaze on body parts to differ with respect to impression words in formal scenes. In future work, we intend to develop a method for predicting impression words using machine learning and deep learning techniques. Thank you for your attention.